All right, let's get right into it. The Matrix. And no, I'm not talking about the movie. We're diving into a really wild connection today, something that sounds like it's straight out of science fiction, a secret link between the birth of quantum physics and the absolute cutting edge of artificial intelligence. So you gotta ask yourself, right? What could possibly connect the bizarre world of 1920s quantum theory with today's most advanced AI? I mean, a physicist trying to figure out the atom 100 years ago and an AI recognizing your face on your phone today? These two things seem like they're from completely different universes. And you can really see that contrast here. On one side, you've got the pioneers of quantum theory, guys staring at blackboards, trying to make sense of a reality that was just breaking all the old rules. And on the other side, you have the inner workings of modern AI, a complex web that's learning and predicting things in ways we're still trying to fully understand. So you have these two massive scientific revolutions. What in the world is the secret ingredient that ties them together? Well, the answer is surprisingly simple, but at the same time, it's unbelievably powerful. It's a mathematical object called the matrix. And trust me, the story of how this one idea went from pure abstract math to world-changing technology, it's just incredible. So to get this, we gotta go back in time. We're not starting in some Silicon Valley tech lab. Nope. We're heading back to the 1920s and we're zeroing in on a brilliant young physicist, Werner Heisenberg, who was staring down a huge crisis in physics. See, for about a decade, the go-to model for the atom was the Bohr model. You've probably seen it. It pictured electrons zipping around the nucleus like little planets. It was a nice, neat picture. The only problem? It was starting to fall apart. By 1925, the cracks were showing. So Heisenberg came along and proposed something totally radical. And bam, within just a year, a whole new way of doing physics, matrix mechanics, was born. And this is the key thing to get. It was a massive shift in thinking. The old idea of these neat little orbits, it was comfortable, right? It made sense. But here's the kicker. You can't actually see an electron's orbit, ever. So Heisenberg basically said, you know what? If we can't observe it, let's just get rid of it. He suggested that we should only talk about the stuff we can measure, like the specific frequencies of light an atom gives off. And the math he used to do that, it replaced familiar things like position and momentum with these weird abstract grids of numbers. Now, this wasn't some tiny adjustment. This was a complete rip it up and start again moment. It was a total break from everything that came before. In a letter he wrote at the time, Heisenberg put it simply, it seems as if the electrons will no more move on orbits. He was literally stepping off the map into a strange new reality defined purely by mathematics. And the story of the breakthrough itself is pretty wild. So it's 1925, and Heisenberg is suffering from a terrible case of hay fever. He escapes to this tiny pollen-free island called Heligoland to get some relief. And it's there, in this moment of isolation, that he has this flash of genius and works out the fundamental math. But it had this really weird property. If you multiplied A times B, you got a different answer than if you multiplied B times A. That's not how normal numbers work. He thought his idea was totally crazy, but he showed it to his mentor, Max Born. And Born had this aha moment. He realized Heisenberg hadn't invented new math. He'd accidentally rediscovered something called matrix multiplication, a concept that back then was basically a toy for pure mathematicians. So, just like that, this obscure piece of math becomes the bedrock of quantum physics. Insane, right? But what actually is a matrix? Let's break it down really quick. Okay, at its core, a matrix is just a grid of numbers arranged in rows and columns. The easiest way to think about it is like a spreadsheet. It's a way to organize data. But the real magic isn't in just storing the numbers. It's what a matrix lets you do to them. And this is where it all clicks. The magic word is transformation. So picture this. You have a set of data, like the coordinates for the four corners of a square. Then you have your transformation matrix, which is basically a set of instructions. It might say something like, rotate this thing 90 degrees and make it twice as big. When you multiply your data by this instruction matrix, poof, you get a new set of coordinates for a bigger, rotated square. This simple process, taking data and transforming it, is the absolute key to this whole story. Okay, so let's hit the fast-forward button. We're leaving the 1920s in the rearview mirror and jumping straight to today. Because that exact same idea, using a matrix to represent and transform information, is precisely how modern AI works. It's the same concept. It's almost 100 years later, And that abstract tool Heisenberg used, it's not just for exploring the weirdness of the quantum world anymore. It is now the fundamental engine driving the entire AI revolution. I mean, just think about where AI shows up. Inside every neural network, there are these weight matrices. That's literally where the AI stores everything it's learned. When an AI looks at a picture, it's using filter matrices to scan for edges and shapes. When you talk to a chatbot, matrices are helping it keep track of the conversation's meaning. It's the same tool everywhere, doing all the heavy lifting. So, how does an AI actually learn anything? Well, those numbers inside the weight matrices, they aren't set in stone. When the AI gets an answer wrong, an algorithm called backpropagation goes back and makes millions of tiny, tiny adjustments to all those numbers. It's like fine-tuning millions of little dials, nudging the whole system a tiny bit closer to the right answer. That process, repeated over and over, is how the machine gets smarter. The matrix itself is the thing that's learning. And on top of that, matrices are also super efficient. There are these clever techniques, like one called PCA, that use matrix math to find the absolute most important patterns in a mountain of data. It's kind of like finding the essence of an image or the skeleton of a dataset. This lets an AI take something huge and complex, like a high-res photo, and compress it way down, keeping only the important stuff and throwing out the noise. This is what makes a lot of these massive AI computations even possible. So let's just step back and look at the big picture here. What we've seen is this one abstract idea, the matrix, take this absolutely incredible journey, from helping us understand the fundamental secrets of the atom, all the way to powering the algorithms that are literally reshaping our world. And this table just lays it all out perfectly. You've got one tool powering two completely different revolutions. In quantum mechanics, back in 1925, the matrix represented the physical state of a particle. Today, in AI, it represents data, pixels in an image, connections between neurons. Back then, matrix multiplication was used to predict how a quantum state would evolve. Today, it's used to transform data as it passes through a neural network. The goals couldn't be more different. One was to understand reality, the other is to create intelligence, but they're both running on the exact same mathematical engine. It's just mind-blowing. And that really leaves us with one last fascinating question to chew on. We've just seen how a tool, once considered nothing more than a curiosity in pure math, ended up being the key to two of the biggest scientific breakthroughs in human history. So it really makes you wonder, doesn't it? What abstract idea, sitting in some obscure academic paper right now, is going to be the essential world-changing technology of tomorrow?